Okay, in this demo I demonstrate the segregation of application A and application B as described in the blog. Okay, so here I'm logged in as application A user, and I'm trying to create a deployment for myself in namespace A. So this succeeds. Right, so all the pods are running in namespace A. So I'll try to execute the same for namespace B, and since this user does not have access to namespace B, the deployment is not going uh, to succeed. So here you see that there's error, and if you do the same thing for the user B, you will get the same results. So application, I'm logged in as application B user, and I create a deployment in namespace B. Yeah, so this succeeds. So now let's look at the quota, resource quotas which are defined for these users. Okay, so there are 3 pods which are running, and each user has been given a quota of 400 M CPU, and each pod takes 100 CPU, 100 M CPU. So now in this command, user B tries to extend his deployments to 5 replicas. So that will mean that there are 500 M CPU he needs, while the quota is 400 M. So you see only 4 are running and the 5th one is not, and to actually see the error we have to look at the replica set. Right, so we on describing the replica set, you see that the error is because this particular user has tried to exceed the quota that is defined for him or for the namespace. Right, so next we look at the network isolation. So I've created two test pods in namespace B and namespace C, and I am logging into application the namespace C pod now. And from, if you have looked at the code, you will know that the connectivity to namespace A is allowed from namespace C but not from namespace B. So here I am trying to access a web service which is running in namespace A from namespace C. So you will see that this succeeds. You are able to hit index.html which is provided by the web server running in namespace A. So here I am logging into the test pod running in namespace B, and if I execute the same command here, so this is not going to succeed. Okay, so this will just hang over here. So using network policies you can achieve network isolation. There are and it is described in the blog. So next we have to look at the physical isolation. How do we achieve that between two applications, application A and B? So this command gives you how many pods are running in particular namespace on and on which node they are running, right? So you see that application A is running on 2 nodes, and that's H and W. And if you look at, so I'm deleting the test pods which were created in namespace B and C. So now we look at on what all nodes application B is running. Right, so if you see from this command and the previous one that we had executed, application A and B both are sharing a node which is H and and something and 6G. Right. Now to achieve the first step we have to take to achieve the isolation is label the node. So this particular node, that is HN6G, something like that, we are going to label it for application A. And once it's labeled, we recreate the application to select that node. Just give it a moment. Yeah, so you see that application A so you see that all the application pods for application A are running on the labeled node. Okay, but if you look at the pods for application B, they are also running on the same node, right? So you have to understand that node selector is a selection criteria. It does nothing to reject the applications which do not select that particular node. Okay, now to achieve that rejection for the other applications which are not supposed to be there, we have to use taints and tolerations. Taints are something like labels which are applied to the nodes, and so here I am applying a taint app equal to app A onto the node which is labeled for application A. Yeah, so the taint has to match exactly with the toleration that we'll define in our application. So now the taint is applied. Now the function of the taint is to repel any deployment which does not tolerate this particular taint. So you'll see that application A is being recreated and application B is has started as well. So now let's look at where the pods are running. Yeah, so application B has been kicked off to some other node, so it is no longer on the node which is labeled for application A. But now look at the application A. Yeah, so none of the pods are running. The problem with application A is that the node selector was configured to select a node which was labeled as application A, but that node has been tainted as well. Now in this case there is nothing or no node is available for this particular application to run unless an application A defines a toleration for this taint. So let's do that next. We'll recreate the application with the toleration for this taint. Right, so we have recreated the application, and if you now look at the pods, they will all be running. Okay, and now let's look at where application A and application B are running, on which nodes they are running. So now application A is running on the labeled node and application B is running somewhere else, okay, on some other node. So we have achieved physical isolation as well, but there is a problem, and the problem is that both the toleration and the node selector are defined by application owners, and there is nothing that stops application B to use the same toleration and node selection criteria. So here application B user is trying to create his application with the same taint and node selector criteria which application A had. Right, so now let's look at where application B pods are running. Alright, so you see that application B is also now running on the label node for application A. So how do we stop it? Right, so this is something that should be controlled, and we do that using admission controllers. But before I show you that, we'll revert back this particular deployment of application B, and then try this again after the admission controller has been defined, and see whether this will still work out. Okay, so now application B is back onto some other node, that means node other than the labeled one. So now we'll go ahead and create our constraints or the configuration constraints, and for that I have to log in as an administrator. So I am using OPA gatekeeper, as if you have read the blog, right? So I have used OPA gatekeeper to define these constraints. Now one of the constraints that I'm going to am using in this particular definition is to say that only a combination of namespace A and a taint ape A is allowed. If anybody comes with a namespace B and try to use a toleration app A, that should not be allowed. Yeah. So here I have defined a constraint template, and we can see the code there, and based on this template we define our constraint for namespace A. So there are two things here, right? So we have to understand, one is constraint template, which is a generic definition of what is it that you want to implement, and other is the specific template for a given condition. So now I'm logging in back as application B, and we'll try to execute we'll try to redeploy the application for a toleration, right? The application A toleration. Yep, so this fails, and the error that you see is you cannot use app A toleration with app B namespace, right? So this is not allowed. So we are only allowing app A toleration in app A namespace.